Now, disordered energy can be changed into ordered energy only with organizational effort or work input. For example, when water in a refrigerator which freezes and become more order, it is due to work is put into the refrigerator cycle, the process in which the net effect is an increase of order which always require an external input of energy. For such a cases, there is always increase of disorder somewhere else rather than increase of more order. Now, reversible systems look sensible when a movie runs backward. Remember those old movies where two high-speed trains were running on a same track in an opposite direction. They stopped inches away from each other in order to avoid the impact. How is it possible? Is it complex? No, it is simple. Both trains began at rest inches away from each other and went backward and gaining the speed when movie was reversed. Then both trains were seen to move towards each other. And one thing you have to remember, all natural processes in the universe are not reversible. Since energy tends to disperse, that is, hot air in a hot oven disperses when oven door is opened. Then energy tends to degrade when energy stored in a chemical bond of a wood degrades when wood is burned. So entropy is the term we use to describe the natural dispersing or degrading of energy. So entropy can be measured by amount of disorder in a system. More entropy means more dispersal of or more degradation of energy, since energy tends to disperse and degrade with time. Hence, the total amount of entropy in any system tends to increase with time. Whenever a physical system allowed to distribute its energy freely, there is always increases of disorder or entropy, while energy of the system remaining available for doing work decreases. So entropy is nothing but how much disorder in a system. Now the net entropy in the universe continuously increasing. We say net because there are some regions in which energy actually being organized and concentrated, which means that in these cases energy increases and entropy decreases, which occur in living organism, in which they survive by concentrating and organizing energy from the food sources. All living organisms such as bacteria to trees to human, they all extract the energy from the surrounding and use it as increase of their own organization. For example, we are humans. We eat, we gain energy, which means that we are growing and referring by surrounding energy. Hence, in living organism, entropy decreases. But order in a life form is maintained by increase of disorder or increase of entropy somewhere else, resulting in net increase of entropy. And here is the important thing. The energy must be transformed into living system to support life. When it is not, organism soon dies and tends towards disorder. Now, there is an interesting thing about second law of thermodynamics or law of increasing entropy. That is, there is even more improbable states may occur. That is, entropy may sometimes decreases. For example, when random motion of air molecules could become more orderly or more harmonious in a corner of the room. See this image. Now, when all coins topple to the floor and they all could come up heads. So remember, these all situations are only possible one but not probable one. So second law of thermodynamics tells us most probable course of events, not only the possible one. Finally, entropy can be expressed mathematically. That is del S equal to del Q divided by T. Meaning of this equation is the increase in entropy del S of a thermodynamic system, which is equal to the amount of heat added to the system, that is del Q, which is divided by temperature T at which heat is added. I hope you got the entropy. Thanks for watching. See you in the next video.